first lesson for Algebra 1, we're going to be discussing variables and expressions. Before we do, we're going to talk a little bit about the history of algebra. And algebra was actually invented by multiple societies many years ago, as far back as the Babylonians 4,000 years ago. And the word algebra comes to us from an Arabic word, algebra, and it's named in honor of an Arabic mathematician who wrote a math text in 832. And the reason algebra is important is that it allows us to solve real-world problems in fields like architecture, engineering, and science much more quickly than we could with math, with arithmetic. You could certainly use trial and error to make economic projections, but it would take a very long time. Algebra is much quicker and more efficient. So starting out with some definitions. First, what you'll see throughout algebra are variables. A variable is a letter of the alphabet that is used to represent an unknown number. And it could be any letter, but the most common ones that you're going to see are X and Y. So when you see these letters, it's telling you we don't know what this value is. It could be, and we can substitute in different values for X and Y, but when you're working with it in an equation, you can manipulate it using operations such as addition and subtraction, just like you did in arithmetic. Okay. An algebraic expression consists of variables and numbers that are combined using arithmetic operations. For example, an algebraic expression is 5x squared plus 2x minus 3. And what I have here are some variables, x squared and x. I have numbers, 5, 2, negative 3, and I have operations. Remember that operations are actions performed on numbers: addition, subtraction, multiplication, and division. And something you'll notice, though, is that we no longer use an x, usually, in algebra to indicate multiplication. And you can see how that would be confusing if we used x. Look at 5x squared. What I'm actually saying is 5 times x squared. But if I were to write that as 5x squared, that would be very confusing. Because is this saying times or is it another variable? Therefore, to indicate multiplication, there's a couple things that can be done. We can either put a dot, so you'll see this, 5x squared, or frequently, we just put the two numbers right next to each other, 5x squared. So 5x squared really means 5 times x squared. In this first example, we're going to take a sentence and write an algebraic expression for it. And it's a similar idea to writing an expression for a problem in using arithmetic, where no variables are involved. You take a similar approach. The first thing I'm going to do is look at what operation or operations are being performed. And I see that it says 8 less than the sum of the numbers m and n. Well, less than indicates subtraction. 8 less than. The temptation, though, is to write 8 minus, but that is incorrect. What this is saying is that I'm taking whatever comes after and I'm subtracting 8 from that. If I say that the number of apples that Justin has is 8 less than the number of apples that Haley has, I'm going to take the number of apples Haley has, say 15, and subtract 8 from that. Therefore, when you see something less than, and then a term or an expression comes after, you're actually going to put minus 8 after that second term. Okay, so I know that I'm going to have 8 less than this whole phrase. So let's go ahead and translate that phrase. The sum of the numbers m and n. Sum tells me I am adding. So I had subtraction, and now I have sum, so I'm adding. I have variables. M and N stand for numbers that are unknown. And I treat them the way I would a number in that they can be added. M plus N. So this is telling me I have 8 less than, so 8 less than this sum, m and n. M plus n minus 8 is the algebraic expression described by this sentence. The second example is an example involving another algebraic expression, but this time with a product, so multiplication. The product of the square of x and the cube of y. So product is telling me that I'm going to multiply. And I'm multiplying two things, the square of x, so a variable, and the cube of y. Again, in algebra, we're going to avoid using an x to show multiplication because that's too confusing. If you're going to multiply in algebra, you simply use a dot. You can use parentheses, the two numbers in parentheses next to each other, or simply just put the two variables or numbers next to each other like this. Okay, so I have the product of the square of x. That's telling me I'm going to take x and I'm going to square it times the cube of y. Y cubed. So this is x squared times y cubed. Or I could have even just left the dot out and written it as x squared y cubed with no dot in between. This one's a bit longer and more complex. Write an algebraic expression for the sum of 3 times a and 6 divided by the difference of 4 times f and 7 less than c. So let's take this one section at a time. This first clause before the comma is the sum of 3 times a and 6 divided by. So this entire first section is being divided by this whole second section. So I'm going to go ahead and write a fraction bar. And in the numerator, I'm going to have the sum of 3 times a and 6. Sum is telling me to add. So up here in the numerator, I'm going to be adding. And what I'm adding is 3 times a, multiplication, and 6. Okay, so I have the sum of 3a and 6. I'm taking that entire expression and dividing it by the difference. Difference tells me subtract of 4 times f and 7 less than c. So I am subtracting two things. The difference of 4 times f and 7 less than c. Okay. Difference is subtraction. So first I have 4 times f. A little more complicated over here because again we have that 7 less than c. Remember, 7 less than does not equal 7 minus. In fact, it's going to be something minus 7. What this is telling me is that I have c, and I'm going to have 7 less than that. I'm going to take 7 from c. When you're dealing, especially with a more complex sentence like this, it's a very good idea to go back and double check your translation. Okay, so I had the sum of 3 times a and 6. That's 3a plus 6, that's sum, divided by. I'm dividing that sum by the difference of 4f, so 4f minus 7 less than c, which is c minus 7. So this expression, this is the algebraic expression for this complex sentence that we were given. In the fourth example, again, I'm talking about products, so multiplication. The product of 4 times x squared and 5 less than 2 times y. product. So I'm going to be multiplying two things. I'm going to be multiplying two things. And I look at what I'm multiplying, and it's 4 times x squared. It's asking me to multiply that, and so I'm multiplying 4 times x squared and 5 less than 2 times y. 5 less than, we've got that by now, that I'm going to put the minus 5 last. Therefore, I have 2y minus 5. So it's 5 less than 2y. Going back, because even though this was short, it was somewhat complex, I'm going to go back and check this. The product of, so I am multiplying. And what I'm multiplying is 4 times x squared and 2 times y minus 5. Okay, today we introduced some definitions that are going to be used in algebra and talked about how to translate a sentence into an algebraic expression. Today we'll be covering order of operations. In mathematics, an operation means that we are performing an action, such as adding, subtracting, multiplying, or dividing. And at times it makes a difference what order we do these operations in. For example, 4 plus 10 divided by 2. So if we have this expression and I'm asked to solve it, I might look at it and say, okay, 4 plus 10 is 14. And then I'm going to divide that by 2, and I'll get 7. You might look at it and say, okay, 4 plus 10 divided by 2. 10 divided by 2 is 5. 4 plus 5 equals 9. So now we have two different answers, and it's going to be very difficult to get anything done or communicate if people are working by different sets of rules. So order of operations is the common way in which everyone looking at an equation or an expression knows to approach so that we come up with the same result. Here are the rules for, or procedure for, evaluating an arithmetic expression. And this applies to arithmetic expressions and algebraic expressions, which contain variables. First, evaluate expressions inside grouping symbols. Grouping symbols include things such as parentheses, brackets, and braces. So parentheses look like this, brackets, and braces. These are all grouping symbols, and we're going to eliminate those first. Once that's done, we'll go through the equation and evaluate powers. So if I have 3 squared, I'm going to turn that into 9 before I go on. After I've removed my parentheses and other grouping symbols and evaluated the powers, I'm going to go through and multiply and divide from left to right. And you start out from the left, and if you hit a division operation first, do that. Then go on, maybe you'll see some multiplication, then another multiplication. So either one that you hit first, going from left to right, handle that. After that, my next step is to add and subtract, again from left to right. So I start out the left side of the equation. If I have something to subtract, I do it. Go through, add, and on through until I have my results. So eliminate grouping symbols, evaluate powers, multiply and divide proceeding from left to right, add and subtract from left to right. One note, a fraction bar can actually function as a grouping symbol. For example, I could have the expression 2 times 5 plus 4 minus 5 squared divided by 4 minus 3 plus 7 squared plus 9. In this case, this fraction bar is a grouping symbol. What it's doing is separating the numerator from the denominator. And it's telling me that I need to handle the numerator, get a result for that. Then I need to find the result for the denominator separately. Once I have those results, then I'm going to divide by whatever it is I've found in the numerator and divide that by the result in the denominator. So a fraction bar can act as a grouping symbol like parentheses. Applying this to our first example. Remember, my first step is to evaluate or solve inside the grouping symbols. Well, I look through here and I don't have any grouping symbols, so I move on to the next step. Remember that the next step is to evaluate powers. Beginning over here on the left, 12 minus 3, and I have a power. I have 2 cubed. So 2 times 2 is 4, times 2 is 8, plus 9 squared. So it's simply 9 times 9, which is 81. Times 4 minus 18 divided by 3. I look through, I've evaluated all the powers. Now I'm going to multiply and divide from left to right. So I'm going to begin on the left side of the equation. 12 minus 3 times 8 is 24. Okay. I proceed along from left to right. 12 minus 24. Now it's going to be plus 81 times 4. 81 times 4 is actually 324 minus 18 divided by 3. All I have left to get rid of in terms of multiplication or division is the 18 divided by 3. And that's 6. Negative 6. Okay. I'm down to my fourth step, which is add and subtract from left to right. Starting at the left, 12 minus 24 is negative 12, plus 324 minus 6. Combining negative 12 and 324 gives me 324 minus 6. Oops, actually it gives me 312. So 324 minus 12 gives me 312 minus 6. And the result is 306. So I went in order, following the rules for order of operations, no grouping symbols. So I went back and I evaluated my powers. And I had 2 powers, which is 2 cubed and 9 squared. And I eliminated those. I solved those. Then I went down, proceeding from left to right, and solved all the multiplication and division that I had. Once I was left with only addition and subtraction, I went back to the beginning, to the left side of the equation, went through, to the left side of the expression, went through, solved, adding and subtracting, until I came up with my final result of 306. Applying this to another example. This time, we do have grouping symbols. We have parentheses and brackets. When I have brackets and then I have parentheses inside, I'm going to work on the inner set of grouping symbols first. I'm going to evaluate my power first because it's following order of operations. Then I look inside the parentheses and all I have left to do is to subtract. And that's going to be simply 7. So I eliminated those parentheses, minus 6 times 3. Okay, I got rid of my parentheses, but I still have some brackets here that I have to get rid of. I look inside the brackets and I see I have no powers. I do have multiplication. So I'm going to get 7 minus 18. Now all I have left is subtraction. Okay, looking at what I have left. I'm going to go back to the beginning of the equation and see that I I can't do anything further here. I'm down to negative 11. Could eliminate those brackets, actually, and then I look from left to right and see that I do have some division. So multiply and divide from left to right. Okay, so I have 4, and then I have plus negative 11 divided by 11. So that'd be 4 plus negative 1, or more simply, 4 minus 1. Finally, I'm going to add or subtract. Okay, so 4 minus 1, that gives me 3. I would actually evaluate powers, if there are powers, for that second step. Okay, so first I eliminated my grouping symbols, which did require me to evaluate powers, divide or multiply, subtract. So I took care of that until all I had was negative 11. And then I went back and I divided, subtracted, and came up with 3. And if I had approached this a different way, if I'd done this in a different order, I probably would have come up with a different answer. So that's why it's important, in order to get the correct answer, to follow order of operations. In our third example, we have a fraction bar as a grouping symbol. It's separating the numerator from the denominator. Handling my grouping symbol first. The way I'm going to handle this is to evaluate my numerator, then evaluate my denominator, and then I'm going to divide the numerator by the denominator. Using my typical order of operations on the numerator, I don't have any grouping symbols within that numerator, but I do have a power. This becomes 3 plus 4 times 6 minus 25. Multiply and divide from left to right. So my denominator is just staying the same. Now I'm going to multiply 4 times 6, so that's going to give me 24, minus 25, still no change on that denominator because I'm handling it separately. So now I have 3 plus 24 minus 25. That becomes, going from left to right, 27 minus 25. Okay, now that's simple. 27 minus 25 is simply 2. Okay, so here I handled the numerator. So moving over here, I'm going to work on the denominator. And I have 2 divided by 4 times 3 plus 7 divided by 4. And don't forget the fourth step, add and subtract, again from left to right. Okay, I need to remove the parentheses first. 2 divided by 4, and that becomes 3 plus 7 becomes 10. Going on, I have some multiplication and division. So it's 40 divided by 4, or 2 divided by 10. So you see what I did is I got my result in my numerator, which is 2, and then I got the result in the denominator, which is 10, and I'm going to divide those. And I can simplify this further to 1/5. So when you have a fraction bar, handle the numerator and the denominator separately, and then divide the results. Our fourth example is a little bit different because we see some variables. However, they actually give you the value for each variable. They're telling me to assume that x is equal to -3, y is equal to 4, and z is equal to 3. So I'm going to go ahead and substitute in. Every time I see an x, I'm going to simply substitute -3. and that's going to give me negative 3 squared minus 3. If I have a y, then I'm going to put in 4. So that's 4 squared plus, and instead of z, I'm going to substitute in a 3. So 2 times 3. Now I can go ahead and follow my usual order of operations. First, eliminate grouping symbols. So I go inside these parentheses, and I'm going to evaluate the power. After I've eliminated the power inside the parentheses, I can go ahead and multiply or divide, and I do have some multiplication that needs to be done. And let's see, almost done with the parentheses. What I'm going to do next is simply add, and that's going to give me 22. Okay, so I got rid of that set of parentheses, so I'm going to look at what I have next. And if you need to jot this down until you have it committed to memory, then do so, but you need to get these rules down committed to memory because you're going to use them constantly. So I did my grouping symbols. Now I'm looking at powers, and I do have a power. Negative 3 squared is negative 3 times 3, and that's 9. Multiply and divide. I do have some multiplication. And finally, add and subtract. And 9 minus 66 is negative 57. Again, the first thing I had to do here was substitute in the values for the variables. Then I had to eliminate my parentheses, evaluate a power, multiply, subtract to get negative 57. So today we covered order of operations, which is fundamental to all math, including algebra, and it's something you're going to use throughout the course.